All right, the second way to solve a system of linear equations is by a process called elimination. And what you do in elimination is I want to, in front of either the x values or the y's, it doesn't matter which, I want to create coefficients that are opposites so that when I add the equations together, the variables will cancel. So what that means, for instance, if I was going to eliminate the x's on this problem, I've got a coefficient of 3 here, a coefficient of 2. So the common multiple between 3 and 2 is 6. So what I want is I want to have a 6 in front of one of the x's and a negative 6 in front of the other. It doesn't matter which one. That way, when I add the equations together, the x's will cancel. So what I'm going to do is I'm going to multiply the top equation by 2 and the bottom equation by negative 3. You might be saying, well, why did you do 2 and negative 3? Could I do a negative 2 and a positive 3? Yes. One of the coefficients has to be positive, one negative, so when you add them together, they cancel. Now, we chose to eliminate the x's. We could have eliminated the y's, and just in case that would have been your tendency, notice I've got a 4 and a 3. The common multiple between 4 and 3 is 12. But also, what would save me just a little bit of time, I guess, is that I've already got my negative accounted for. So if you wanted to eliminate the y's, I'd multiply the top equation by 3 to get a negative 12 here, and the bottom equation by 4 to get a positive 12. It doesn't matter whether you cancel the x's or the y's, just make progress. So I'm going to continue along. I'm going to eliminate the x's. So 2 times 3x is 6x. 2 times negative 4 is negative 8y. 2 times 1 is 2. My bottom equation, negative 3 times 2 is negative 6x. Negative 3 times 3 is negative 9y. And negative 3 times 12 is negative 36. And now here is the whole purpose of the elimination process. When I now add these two equations together, 6x and negative 6x, those cancel. Great, no more x's. Negative 8y and negative 9y is negative 17y. 2 and negative 36 is negative 34. And when I divide both sides by negative 17, I get that the y value is 2. Now, once again, your answer should be an ordered pair because we're finding where the two graphs intersect. So this is not done. You're only half done with the problem. I'm going to take the y value of 2. You can use any equation you want. I'm just going to use the top equation. I have no secret reason for doing that. So I've got 3x minus 4 times y, which is 2, is equal to 1. So that's 3x minus 8 equals 1. When I add the 8 over, that's 3x is equal to 9. When I divide by 3, that's x equals 3. And so last thing to do, good notation. I'm first going to notate this as an ordered pair. The x value is 3, the y value is 2. And then to differentiate this from an interval, I'm going to put it as a solution set. And so that is the point that forms my solution set.